Hello guys, in this video I'm going to show you how to solve smallest subarray with sum. So given an array of positive numbers and a positive number s, right? Find the length of the smallest contiguous subarray whose sum is greater than or equal to s. Return 0 if no such subarray exists, right? So example, given this array of positive numbers and s is 7, so can we find what is the subarray that sum up to 7 or greater than 7, right? What is the smallest subarray? For this kind of problem where you have to find the subarrays, contiguous subarrays of certain size, and you have to calculate the sum of the subarray, then probably think of sliding window technique, right? So we can create a window, right? It simply just 2 pointers, start and end, right? So we have start and end. So we can expand window and we can shrink the window down. Probably until it satisfies the requirements here, which is sum is greater than or equal to s, right? So let's see what is the logic of sliding the window. Probably as every sliding window problem, we started the window is, we have 2 pointers, right, to which determines the size of the window, the position of the window, right? So initially it started at 0, right? So now for this window, the current sum is 2, right? Let's say we don't have a mid length yet, right? So let it infinite. Leave it infinite. Current sum is 2. It's obviously not greater than 7, right? So it's not considered a good window because its sum is too small. So we want to expand it out, right? We want to expand the window one step, right, to the right. So we gradually moving toward the target, right, which is 7 here. Okay, I'll sum it up 3, right? So sum it 3 is still too small. Let's expand it a little bit. Now it's 8 here, so it good enough. Good enough window. The mean length. Okay. It satisfies the constraint, which is greater than or equal to s. S is 7 here. So we want to update our mean length, the current mean length, to 3 because the size of the window is 3. It is the correct one. So let's say we are at the current window is good, but we want to find a better one, because the goal here is to find the smallest contiguous subarray, right? So how to find a better one? We can move the move the left, shrink the window from the left, right? So it is simply by moving the left pointer rightward one step rightward. Okay, so now it is 6. It is not a good one, right? It's smaller than 7, so we're not going to update the min length here. Okay, so now it is smaller than our target, so let's expand it down. Okay, it's 8. Now we want to update the min length, but it is not better than 3 here. The current side window is 3. It's not better than current one, so we're not going to update it. So can we find a better one? Let's move the left pointer rightward, right? We have a new window. Okay, it's 7 now. Okay, 7 is greater than or equal to 7, but the min length in the length of the window is 2, right? So we want to update the min length here to here we want to because the okay again we ask can we find better window, so we move the left pointer rightward, shrink down our window. Okay, consum now is too small, so we don't want to update our min length. Again, let's expand our window. It's now 5, still too small. Okay, expand again. 7. But size 3, it is not better than current min length is 2. Will not update it. So okay, can we buy better window? Shrink the window down. Okay, it's now 5. Consum is 5, and it is too small, so move the right pointer rightward. It is out of range, so we exit our processing, right? It's probably in the loop. So okay, let's code it down with the logic that I explained. Okay, we need 2 pointers. Let's say window start and window end. Window start is 0 initially. We need to keep track of the current sum as well. Current sum initially is 0. We need keep track of min length, current min length, initially is infinity, the biggest number. So for the first one, it will always less than infinity. So we're gonna update it, right? Update the min length. So we're gonna gradually expand our window. Okay. One step at a time. Window n is equal to 0. Window n less than sum. So sorry, array length. So each window n here is get out is greater than the last index, right? Then we'll exit the loop, right? Okay. Window n plus plus. So for each step, I want to probably add the, here we're expanding, right? So at the beginning of each iterations, I want to add the latest number to the current sum equal to array at window n. Okay. So after adding to the current sum, then I want to check it. I want to check if the current sum is greater than the sum, target sum here, then want to shrink down the window, right? But probably this is a while loop because we want to shrink down our window as long as the current sum is still greater than sum, right? So we don't want to just run a one loop, right? We want to shrink down as long as this is true. Okay, we shrink down it by we must update our current sum, right? Current sum minus what the number at the start of the window, which is array window start, right? Then window start increase by 1, right? Wait a minute. If the current sum is greater than this, probably I want to update my min length first. So my min length will be the minimum values of current one and the current size of the window. Current size window is window n minus window start plus 1. Okay. So if the current size is smaller than min length, it will take this one. Otherwise, it's still min length. Okay. So after all, because here is infinity, so if the min length is still equal to infinity. I'm going to return 0 if no such array exists. Otherwise, I will return min length. Okay, let's run it. Just sliding window 3. Okay, it works. So that's it for our problem. Well, thanks for watching. See you on the next video.